Now the topic is temperature of ocean water. Sources of temperature of ocean water. The main sources of temperature of ocean water is the insolation, that is incoming solar radiation. Ocean gets energy or heat from the sun, and due to insolation ocean surface received uh, EMR on the topmost layer of the ocean and gets energy or be warm. And second important attributes of the ocean temperature is the submerged volcanoes. Through the sea floor spreading and due to submerged volcanoes, a minute amount of energy or heat comes to the from the interior of the earth, and ocean gets warm or get energy from the submerged volcanoes or through the process of sea floor spreading, and its energy come from the vent as a heat or the other source of energy. So basically ocean gets warm due to insolation, due to received EMR from the topmost layer of the ocean floor, and ocean gets warm through the submerged volcanoes and its related eruption from the bottom part of the ocean floor. The temperature of the ocean water is not uniformly distributed. There is horizontal and vertical variation. The horizontal variation of the ocean water temperature is normally described by the surface ocean temperature. This is nothing but the horizontal distribution of temperature distribution of ocean water. Normally, we are all familiar that suppose this is the earth and this is the equatorial zone. An equatorial zone or the low latitude zone received more insolation, received more EMR due to the reason that sun rays reached to the equatorial region almost at perpendicular or the angle of 90 degree. Due to this perpendicular EMR, the equatorial region or low latitude zone received more EMR. So equatorial areas gets more heat, more EMR, and the amount of heat absorbed or EMR absorbed per unit area is larger than the pole. Obviously, the temperature of the surface water of the equatorial region is higher than the pole. Okay, but we are all familiar that due to northern oscillation and southern oscillation, or due to apparent movement of the sun, the trade wind belt and the pressure belt and the planetary wind belt shift 5 to 10 degrees north to south due to the northern oscillation and southern oscillation. So this high temperature zone, this is high ocean temperature zone, shift northwards north and south due to the apparent movement of the sun, due to the apparent migration of the planetary belt or the pressure belt due with the variation of the season. Okay, now come to the vertical distribution of temperature. That is nothing but a changes of temperature of the ocean water with the increasing of the depth of the ocean. So surface ocean is more warmer because surface of the ocean areas, surface areas of the ocean gets EMR. Obviously, the surface layer of the ocean is the most warmest part of the ocean water, and temperature of the ocean water decrease with the increase in the depth. So topmost layer of the ocean is warmer, that is due to insolation or EMR, received EMR. With the increasing of the depth of the ocean water, temperature decreases. So there is an inverse relationship. This is the simply in the cases of equatorial region. Here in equatorial region, surface temperature of the ocean water is comparatively higher than its lower part. Okay, but in polar region, the heat input at the surface is low due to inclined sun rays, due to lesser EMR, due to very low and inclined insolation, and so there is not large contrast or large changes of temperature with the increasing of the depth of the ocean water. Okay, so depth of the ocean water and the temperature plays a very significant role in water density and also the salinity. Okay, so now come to the point of thermocline. Thermocline means thermo comes from the thermal, that's related to heat or energy, and cline comes from the inclination. Okay, that the word comes from the thermal and inclination, and that is the thermoclinal condition. What is thermoclinal condition? It's related to the vertical distribution of temperature of the ocean water. So temperature of the ocean water from the surface of the ocean to the bottomest part of the ocean to increasing the depth of the ocean water, temperature changes. That rate is not the uniform, or that decreasing rate of the temperature or with the depth is not the linear. There is a variation. That variation explained by the graphically plotted by the thermoclinal line. Okay, here the temperature undergoes the significant changes with the increasing of the depth of the ocean water, and that is defined by the thermoclinal line. Okay, in winter and summer, there is a variation in the thermoclinal condition. In summer, suppose this is an equatorial region. So equatorial region surface of the ocean area received EMR, more EMR. So the temperature in the topmost layer is very high. Okay, when someone moves from the topmost layer to the depth of the ocean water, with the increasing of the depth of the ocean water, temperature gradually false. There is an inverse relationship. Surface temperature of ocean water is high. With the increasing of the depth of ocean water, temperature begins to fall. So there is a sharp contrast. There is a wide gap of the temperature in the topmost layer of the ocean due to high EMR during the summer, and the temperature is comparatively low in the lower part of the ocean. So the contrast of the thermoclinal line is comparatively higher in summer. Okay, and the contrast of the thermoclinal condition is higher in summer. But in winter receive lesser EMR in the topmost layer of the ocean. So temperature is high, but not so high like a summer, and gradually temperature falls with the increasing of the depth. So here the gap of the temperature of the topmost layer and bottom part of the ocean is minimum. So minimum, here it is maximum. Okay, in summer, and in winter it is minimum. So contrast, in the winter the depth temperature of the surface of the ocean and its lower part is minimum. So thermoclinal line in winter and summer is not uniformly distributed. Thermoclinal line, but thermoclinal condition of water is quite towards the isothermal, towards the uniform in winter, but in summer there is a contrast, there is a wide gap in the thermoclinal condition. Normally, the water temperature decreases rapidly with the increasing the depth of the ocean water. Rather, topmost layer of the ocean is warmer than its lower part. Okay. Normally, up to 200 meter, the temperature is more or less uniform, or the isothermal in condition. But below the 1000 meter, the temperature falls very rapidly. Okay, now come to the density of water. Density of water very closely related to the salinity condition and temperature conditions. The density of fresh water is 1000 gram per cubic meter, and normally density of ocean water, it varies place to place, but on an average densities of ocean water at the sea surface is very important. Sea surface is 1027 kg per cubic meter. So ocean water gets more dense as temperature goes down. We are all familiar in climatic condition that cold air is more denser. Similarly, cold ocean water is more denser. Okay, and warm air is lighter, like a warm ocean water is lighter. So cold ocean water gets more dense as temperature goes down. The colder water is more dense. Okay, increasing the salinity also increase the density of the seawater. So salinity and density, there is a relation. Increasing the salinity, it increases the density. So high salinity is related to high density of ocean water, and density also related to the temperature of ocean water. Warm ocean water is lighter and cold ocean water is the denser. Okay, so salinity and the density both are the positively related. If the density is increased, then the salinity will be increased. If the density will increase, then salinity will be increased. And temperature and the density is negatively or inversely related. So lighter with the increasing of temperature of the ocean water, density falls, and with the increasing of with the falling of the temperature, the density will rise. So there is an inverse relationship. A layer of water in an ocean or the certain lake, where the temperature gradient is greater, the warmer layer will be the above or topmost layer, and the colder layer will be the bottommost part. Okay, normally suppose this is the ocean surface. So the topmost layer is the warmest part and bottommost part is the colder. So if there will be a trend. If a layer of the ocean water of a certain lake with the temperature gradient is greater, if the warmer layer is above, this is the topmost layer will be warmer layer, and the bottommost part will be the colder. Okay, then the density of ocean water. The temperature of ocean water decrease as increase the depth of the ocean. Okay, second thing is that density of ocean water increase, and that with the increasing the depth, and the deep ocean layer with the dense water on the bottom and lightest water on the top. This is very important phenomena about the ocean surface. So lighter water in the topmost part and heavier water in the bottommost part. In each and every saline water bodies, the bottommost part is the most denser and topmost part is the lighter. Okay, so salinity, density and temperature are very in place. Salinity, temperature and the density both are interconnected and interrelated. Those are very important attributes in ocean currents and the formation of ocean water mass. That's it. Ocean water. The circulation in the depth of the ocean is horizontal. Suppose this is an ocean body. Suppose this is an ocean body. So dense water in the bottommost part and lighter water in the lowest part. So the depth from ocean current circulation in the bottommost part, the ocean may be horizontal because this is very dense water mass. Okay, and water moves along the layers of same density. So water moves along the same density because this is the bottommost part of the ocean. And temperature and salinity both are directly related to the density, and density is related to the ocean circulation, ocean current, ocean water mass, so on. So the temperature and salinity diagram, sometimes called as a TS diagram. TS diagram is very relevant to identify the density, position and location or origin place of ocean current and ocean water masses. Let's have a look. This axis describes the temperature of ocean water and x-axis describes the salinity. It varies from 33 ppt to 35 ppt of Pacific Ocean. So there is a sharp gradient of temperature and sharp gradient of salinity. Okay. So what is very relevant in water density and related to the ocean current and the formation of water mass. Those are the halocline and the thermocline condition. Both are related to the depth of the ocean water. The changing the thermal condition or temperature condition with the increasing of the depth of the ocean water is normally defined by the thermocline line, and halocline line is nothing but the changes of salinity of ocean water with the increasing of the depth. We can separately plot the thermocline condition with the depth and the temperature condition, and we can separately plot the haloclinal condition too. That is the salinity PPT and the depth. And from that graph, from the information related to thermocline line and halocline line, we can get the equal density line. An equal density line helps to determine the ocean circulation, origin, place of the water masses, movement of the water masses, so on. So normally uh, density of ocean water related to the combination of the two things, that is temperature condition and the salinity conditions. Suppose normally I have told that this is an ocean basin. Normally in an ocean basin, due to high insolation, topmost layer is the warmer due to insolation, and bottommost part is the colder. Okay, warmer is the lighter or less dense, and bottommost part is cold, that is it is denser. This is the situation of normal condition. But if the combination of salinity and the temperature as a peculiar, suppose normally lower density related to the, lower salinity related to the low density, okay, and cold water is related to the higher density. So combination of cold water and low density, then ultimately density will be lesser. So cold water with lesser salinity, that is low density, that water, we can observe that kind of combination of water in the topmost layer. That water temperature is not so high. This is a cold water mass, okay, in the topmost layer due to the combination of salinity and the temperature, and the warm layer, that is high salinity and comparatively high temperature. Normally, high temperature is associated with the lesser density, but the high temperature and high salinity are ultimately responsible for the higher density. So, in that case, reversal situation has been observed. The warm air, cold water, we can observe in the topmost layer of the ocean due to the combination of salinity, that is lowered salinity, and cold water that will found in the topmost layer. That water will be cold, and the warm layer, that is high salinity and high temperature warm water, we can observe in the bottommost part. So this is the reversal situation of normal condition. Cold water we can observe in the topmost layer, and warm water we can observe in the bottom part of the ocean. So here be clear, thermoclinal condition and haloclinal condition, that is the combination of salinity and temperature, determines the position, movement, location of the water mass, and the formation of the ocean current too. In 1916, first time a relation has been established by the scientists, that is the temperature salinity, both are interrelated, and density of the ocean water depends on the combination of temperature of ocean water and salinity of the ocean water. And all these three phenomena plotted through the TS diagram. And density plays a very important role in the formation of ocean current and water mass. We can take a simple example of that. We know all the ocean are connected. It is very difficult to create a watertight boundary among the oceans. All bays are connected, all ocean are connected. Suppose this is the India, and we are all familiar that this is the Indian Ocean. This is Bay of Bengal is related to in the adjacent zone of Bangladesh, that is Bay of Bengal. It is related to the adjacent zone of Arab Desert, that is Arabian Sea. Those are the shallowest part of the Indian Ocean or the Bay of Indian Ocean. And this is the Indian Ocean. And southern part near the Kanyakumarika and Sri Lanka. Suppose this is Sri Lanka, India. This is the Indian Ocean. In the melting zone of three oceans near this Kanyakumarika, the water of Bay of Bengal, water of Indian Ocean, and water of Arabian Sea. Those are interconnected. Those are the part of Indian Ocean. In spite of that, if someone observed the that meeting of the water masses of Bay of Bengal and Arabian Sea and Indian Ocean, we can observe in naked eyes the contrast of the water of the three zone because of the density. Even in naked eyes, we can identify the color contrast of the water too. That contrast is basically due to the density of the ocean water. So density plays a very important role to the conveyor belt of the ocean current, upwelling or the submergence of the ocean currents, and the movement and the origin place of the ocean water masses. Temperature salinity graph, uh, normally known as TS diagram, first time proposed by the Helen Hansen in 1916, and this is very important to identify the water masses zone, to identify the water density, and it helps to identify the conveyor belt of ocean current. This is a diagram, TS diagram. Here the y-axis describe the temperature and x-axis describe the salinity. It varies from 33.5% ppt to 36.5 ppt. So, but here the temperature and salinity merge in that merging point has been identified by, but in diagram there are few iso lines, just like the isobar and isothermal lines. Iso density line has been plotted. Those are the iso density line. Those iso density line determined on the basis of temperature and the salinity. Better to say haloclinal and halothermoclinal line. Isosalinity known as haloclinal line, and isotemperature is known as thermoclinal line. On the basis of haloclinal, that is related to salinity, or on the basis of thermoclinal, that is related to temperature, the equal density point of the water mass, equal density point of the water bodies has been identified. And through the TS diagram, that is salinity and the temperature plotted, and we are all familiar about the plotting of climograph, just like that. And through the help of these two indicator, water density has been identified, and the TS diagram provides the information about the water density zone. So those are the line of equal water density, and this equal water density line determines the movement of ocean current and the movement and the character of the water mass. Okay, and salinity, temperature and density both are the integral parts of ocean circulation and water mass formation. Water mass is the body of the ocean water with a distinctive narrow range of temperature and particular salinity of a particular density, and resulting from the two parameters, that is salinity and the temperature. Water mass is formed as a result of climatic factor of the specific region too. We can take an example of that. Atlantic bottom water mass is a very important and cold water mass. So formation of water mass and ocean current is directly related to the water density of the ocean, and that density determines by the halocline line and thermocline line. Halocline line related to the salinity and thermocline related to the temperature. So the TS diagram, that is salinity and the temperature diagram, that ultimately provides the information about the water density, and that water density helps to identify the source zone of water masses, water mixture pattern, the mixing of the water masses, and the movement of the conveyor belt of the ocean.